So the effects of carbon dioxide in a planet's atmosphere. Hopefully you can see what's happening. You have the surface of the planet here, maybe something like Venus, and you have a lot of CO2 in the atmosphere. Then what we saw happening then was all of these infrared photons just start to get trapped in this region around the planet. So I'm just collectively drawing a bunch of red on here to indicate trapped IR. And like I said in the previous video, IR light here is sort of reserved for what we associate with heat also. So trapped IR light is equivalent to saying sort of trapped heat. And so once again, here's the simulation. It's been running, and you can just see all these red photons trapped near the surface. So I wanted to show you one more thing, because it turns out that there's a similar effect in greenhouses. Okay, so what we're going to do, we're going to build a little greenhouse out of glass. So here comes the sunlight down, the yellow photons coming down, again, the red IR photons going up. And if I add a pane of glass in there, you can sort of see that the effect of glass, here's the glass layer that got added in there, is sort of the same as carbon dioxide. In other words, the glass layer is starting to trap infrared photons in this region right here. And if I turn on, say, a whole bunch of photons, you can sort of see the effect there. They're definitely concentrated in here between that pane and glass. And I can add another pane there if I want. And another pane. So you can see that the glass panes have this effect of trapping IR light. And wherever the IR light's going to be, it's going to be warmer. And that's just what greenhouses are. So greenhouses are these sort of glass or clear buildings that allow sunlight to come in, but they don't let the heat or the infrared escape, so they're nice and warm in there. And that's where the word greenhouse effect even comes from. So here's back to our picture. Let me go back and turn on all the photons again. And you can just tell that when I turn on as many abundant photons as you might see, say, coming from the sun, of course this doesn't do it justice, but it's many more, you can just see how concentrated these photons are near the surface where all the CO2 is trapping them. And so the bottom line is what you get from this here, from all the CO2, is you just get a bunch of heat. Heat near the surface. Heat near the surface, period. That's what you get. And this is the primary reason why Venus is so hot, because it has a lot of CO2 in its atmosphere. CO2 traps carbon dioxide, and the heat just sort of hugs the ground. So Venus, being so hot, a lot of CO2 in its atmosphere. Number two, CO2 traps IR light. Number three, IR light is associated with heat. And 4, if you sort of add 2 plus 3 together, well, you get 5 normally, but really what you get then is you get trapped heat. And so Venus then is the planet, that's the example of a runaway greenhouse effect. That, I think, is the most compelling and important aspect of the planet Venus, is it's a planet that exhibits the runaway greenhouse effect. And the greenhouse effect is essentially these 3 things right here. That is the greenhouse effect. The greenhouse effect is that CO2 traps IR light. IR light is associated with heat. And if you put 2 and 3 together here, you get not just trapped IR light, but trapped heat. And that's what tends to warm things up. And so one of the curious things about this then in studying Venus is, could what happened on Venus actually happen on Earth here? And I'll address that in the next video.